Welcome to Friday Hacks 217, and I hope everyone had a great week so far. So we have two speakers as usual today. So the first speaker will be Ying Hang, and he'll be talking about how to build a Devtool startup in Silicon Valley. So Ying Hang is a Stanford alumnus and founding engineer at Team, a startup that's building a browser-based code editor that's designed for collaboration and can easily integrate with existing infrastructure. So let's welcome him.
Yeah, so today I'll be giving a talk about how to build a Devtool startup in Silicon Valley. And my name is Ying Hang. So so the first slide, so it's a little bit of background about me is that I'm actually studying NJC before and JC basically back in Singapore. And then after that, I went to Stanford to do my undergrad. So I did undergrad in computer science and management science and engineering. And right after graduating, then that's when I started this company called Time. Or actually, I joined as a founding engineer. So I guess the first question is like, what is Time? So Time is basically a startup. And then in this startup, we are trying to build a multiplayer in-browser editor that lets you code on any machine. And you can check it out on time.so. And we started working on this startup in June 2021. So it's just like about 7-8 months ago. So I think it will be best for me to kind of I think it would be easiest for me to kind of show what's Time by like doing a little quick demo. So let me just exit out. And so this is what we've made so far. Time. Okay, this is the landing page. So let me just log in. So basically it's a multiplayer editor that lets me kind of just code on any machine that we want. So let's say I have this is my computer that's live right now. So I can just kind of jump into it and then I open this link and then right, boom, it's like a full-fledged VS Code that has everything that's kind of running. I have terminal access, I can open the code. And the cool thing is like I can just copy this link. Let me just share to another person. Like for example, I share to my friend. Oops, that's because I didn't turn on the permissions. Let me set the permissions. Read access, edit access. So I copy this thing, kind of share it over here. And then someone else like will be able to edit the code together with me in person. So you can see that's like I can see my cursor there, and then they can see the cursor kind of right here. Yeah, so this is on high level kind of what we have built so far. But I'll go into more details about like what is the vision of what we're making further down the road. Yeah, so let's just go back to the presentation. Yeah, so the outline of the talk is, so I'll start off by talking about like the idea of what we're making and answering kind of like why now. And then after that, I'll talk about like what, like for a startup, should you go bootstrapping or should you go for VC funding, and things that you should kind of watch out when you do a Devtool startup that I kind of learned along the way. And then like our first big mistake of what we did when we did a startup. After that, we'll kind of go more into the technical details about like building the product and the grand vision. And then the last part will be like what's next in terms of like what we're doing. So feel free to like shoot any questions in the Zoom chat or something, and I'll like go through it at the end or like some midway through the presentation. So let's start off with a little bit of caveat, which is like first time. It's like a very early stage startup that is still in the process of searching for product market fit. So which means that like by no means like we have achieved any like form of like financial success yet. So it's like super early. And my experience is only but like a single data point in this whole in the whole like sea of startups that are in this Bay Area. And the focus of my talk will actually be on the kind of like the mid-level abstraction of the journey. So there's like high level, like sometimes people give high level talks about like startups and like the entrepreneurship journey, but like sometimes it's not very actionable. Sometimes they give too low level details and things usually don't apply. So that's why I'll kind of go like in the middle. So you can kind of have like a sense of the bigger picture, but also kind of be able to relate and kind of follow through with some of the things that you might maybe pick up from my talk. Yeah, so let me start. So I guess the starting part is the idea. So like every startup, there's always like this founding idea. And there's like basically two school of thoughts. Like it's a spectrum. So on the very left, there's like the idea is everything, where like very Peter Thiel like of a view of startup there, where you have a grand vision and you know what this is gonna be, and what you're doing is just trying to like build a business that just wants to execute out this kind of startup. And on the very right, there is like the market will pull out the idea out of you. So this is very I guess lean launchpad-ish sort of startup idea approach, where like you kind of want to let the market kind of tell you the customers to tell you what you're making, and eventually you kind of refine your product to suit what the market tells you, and it might end up in a very totally different spot from where you started. So actually this the icons are flipped. So all these startups here should actually be on the right side. So there's this whole two school of thoughts, and you'll find plenty of examples that will work either way. So the market that pulled ideas out of you is actually like Lyft, Retool, and Slack. So for those that don't know, Lyft is like basically a competitor to Uber, one of the biggest competitor Uber in the US. And Lyft is actually their original very idea is in the space of ride sharing, but it's a very different starting point. It was about like sharing buses to like for people to go back to their dorms and during like winter breaks and like school breaks. So it was like their Lyft car thing, ride sharing was like a very side project that they actually tried out, and things actually worked, and eventually that became their main business because after trying many different things and seeing what the market wants, they actually finally converged to like making this ride sharing app. As for Slack and Retool, Slack is the famous case of like making like 180-degree pivot of what they made. So Slack kind of started off as like a game developer. They were making a game, like some open-ended game, but then turns out they were not getting a lot of like usage out of it. But so they had to like fire a lot of their employees, and then but then they realized that, hey, like since we took the money of the investors, let's just try to we made this like internal chatting tool that really was really helpful. So perhaps that will be like kind of an entry point of something bigger, and then they pivoted into this and eventually grew to this like billion-dollar company. And similar for Retool, which is a much smaller startup actually, where they kind of started off making this they were in this financial fintech space where they tried to build like a fintech product, but the thing that they were making was not super helpful. But they realized that in the process, hey, actually building internal tools is actually quite troublesome, that it takes a lot of work. So they decided that, hey, let's just try making this fintech tool like something to let people make internal tools to track their metrics, whatever that matters to them really easily. And that's kind of that's like the kind of startups that like believe that market will pull the idea out of you. It's not like the vision that you had. But on the very other end, there are like this companies Figma, Notion, Airtable. So Figma kind of started off as like they were trying to make a designer tool. I mean, for them, Figma is a little bit of a in between because they weren't exactly sure what they were doing, but they knew that they wanted to use web to make designer tools more collaborative, more friendly, and more web native. But they spent like 2 years kind of building the cave and trying out. And then the very similar things happened for Notion and Airtable, where like in Notion, they actually started with a low code tool, realized there's nothing going on, but then they went to the cave and built this like note-taking app that they really wanted themselves. And they kind of knew what the product was. It was not like they kind of like iterated based on the user. I mean, I'm sure they iterated based on user feedback, but they had a very certain idea of where they were going. And the same was for Airtable, where they kind of raised a round of money and like just kind of build in private, where they tested out with like some early users, but they weren't like putting things out there and like, okay, let's see what the market tells me what to make. So there's like this two main school of thought. So the way that I kind of, and like, I guess one thing is like, even when I told you this founding story, this is like based on what I've heard and like what I've learned so far. I think we should kind of be our founding stories like this, because like oftentimes founders, successful startup founders, they tend to workshop their narrative about like the story they tell to make a very compelling story that kind of becomes memorable and something that they can repeat in all the talks they give. So so I guess that's the caveat about all these founding stories. Like it might, when what they tell you might be one thing and what they actually did might be another. So, but regarding this, my take is that like I'm leaning more towards kind of getting inspiration and where we have some sort of idea, but this idea ought to be like motivated, not from like me forcing myself to think of something, but instead just like based on observation in my daily life and or observation that some interesting insight someone told me, and then kind of building towards the vision, but at the same time constantly kind of check for external validation. So to make sure like I'm not just like having some echo chamber, kind of just iterating in the cave and not knowing what's going on, but instead have this vision, but like constantly put parts of it out there to kind of test it to see whether it actually validates that hypothesis that I have. So then the part about, so then we get to like, how do how did my team kind of come up with this idea? So it's kind of part observation, part inspiration. So, and the reason why this startup is called Time is because it's based off this company in the 60s that was called Timeshare, which they kind of pioneered the concept of cloud computing because shared computing, because like in the past computers were very expensive, and then to kind of use computers, you get like slices of usage of the computers where they do kind of run a sequence of code, jump it out, run someone else's code, but then the way you connect it to it is like you kind of, so everyone kind of have their own monitor that connects to this computer, and they just time share the compute. So the reason why I come with this idea was because like it's part observation, part inspiration. So it's like this meme where like I add file to the repository, someone adds something, I commit, my friend commits, I push, then I always like, I realized that when I code, I will often like really try to commit my code and try to push as fast as possible before my friend does it, because like I really hate to do merge conflicts. And I noticed that was a very strange pattern when I was using Git. And then when I took a step back, I noticed like some of my friends complaining about Git. Like I know Git is very powerful as a tool, but Git is also kind of hard to use. Oh, it's not a very intuitive product in the sense that like even after using many times, you might still kind of have to memorize the commands, and it just requires a lot of thinking, a lot of brain power. And so, and the triggering point for me was like when my friends started facing so much issues with their Git merge conflict, which I knew like, yes, after you're going through it, maybe it will get better. And but the fact that like it got to the stage where like people faces lots of frustration, but they kind of take it out on themselves in terms like, oh, actually, maybe the reason why I'm not dealing with this much conflict very well is because I don't know how to use Git. But Git is like supposed to be a versioning controlling tool that helps you to do the job, but instead it seems like it's actually causing people quite a lot of trouble in terms of learning how to use it. So, and then I also took a step back and noticed a few trends, which is like, why now? So one thing I noticed was like, storage is becoming increasingly cheaper. So some of the constraints when Git was made was different from the constraints that we have right now. So when it's made in like the early 2000s, internet was not very stable, and like compute storage, people were still storing the things in hard disk, and SSD is expensive. But now things are getting, storage is like a lot cheaper than what it used to be. But instead, developer productivity is kind of like the main like constraint that we're facing. And the second is like work then is becoming more remote and hybrid because of COVID. And last thing was like coding was becoming more and more common as like both as a profession and just people's interest in it. And as for like why now, that's also an important part about why now for me personally, because like when I was coming out fresh out of college, I knew that was like it's commonly people tell you in the startup world that like when you come out fresh out of university, like that's the maximum probability of you meeting a potential co-founder, because like when you go down the road, a lot of your friends, they'll all like join a company, get really comfortable, and then that's when they have like a very large and noticeable kind of opportunity cost in some sense, because now that they have like this huge job that's like paying them 6 figures, now 6, 7 figures, and they have to like, should I deliberate and join this like scrappy startup which is likely going to fail, or can I just stay in this like cushy job? Things become a lot harder for them to make this decision, I guess. And then the next thing was there's little liability on my side because I'm just fresh out of college. Like I don't have any like mortgage, no car loans, like no children, so it makes the liability issue a lot easier. And third is that like I tend to constantly think about startup ideas. I think that's like one of the interests that I have, and I feel like if I just work for some other tech company, I'll just be spending like all my free time kind of just thinking about startup ideas. So if this is so interesting to me, so I might as well just kind of try to pursue and kind of try it for once and see how things are like. And lastly, like this space of like code collaboration is a problem space that I have lots of familiarity with in terms of usability, just because like I am one of the potential users itself. So I kind of know what to expect in terms of like what is a good product and what is not a good product, or if something is like totally out, as compared to like me working in the space, studying something in the space where I have like zero clue of how people think there. Yeah. So 1 second. So the next part that I will cover is like, should you do as a startup, should you go bootstrap versus like getting external investor funding? So the thing to note here is like things are probably different in Singapore versus the US. Give me 1 second. So one thing you will need to know is that like the way VC funds work is that they will need to go big or go home. And that's not just like something they say to kind of stroke their ego, because the way VC funds work is that the investor that's leading the fund often have to try to use that money to invest in maybe tens of hundreds of startups. And the way it works is that usually, because their time is limited in some sense, they can only meet so many companies, and as a result, they would tend to try to invest in companies that have like a very low probability of success. I guess not the fact that it's low probability of success, but they want to invest in companies that can have like a huge difference in their returns. And because their funding is often, the way they kind of get their funding is like they go to institutions or pension funds, institutions, for example, like GIC or Temasek, or like university, Stanford pension fund, not pension fund, Stanford's what do you call that? Basically the endowment, and then they'll take that money, which is like they'll ask them to give them money, and then once they got the money, they'll tell them, okay, I'll give you you'll get your returns in 10 years. And to get a return, so for them to get the return in 10 years, there's like a lot of lack of liquidity. And as a result, they will need for the fund to return well, to get like a 3x return in that fund over 10 years, they'll need to take some of the money and like 100x some of the money that they got. And once the 100x that money, a little bit of the money they got, and that's when they can be able to cover and hit the returns they need to hit. And that's why a lot of VC funds will actually bet on companies that can become $10 billion company, even though they have just like a small percentage chance of success. But they will not bet on like a company that has like a 50% chance of becoming a $10 million company or $100 million company. Because even though that is a very good outcome, it's a very good outcome for the founders actually if you start a company that becomes worth $10 million, $100 million. It's a humongous difference in terms of your financial situation. It's just not very compatible with like the nature of venture funding. So that's something you have to think about when you're thinking about like whether you're doing a bootstrap or VC funding. You can bootstrap something that you think eventually might become $1 billion company, but it will be hard for you to raise VC funding if there is an obvious upper bound to the size of the company that you can create. So an example of like a company that's like a Devtool company actually, that is not like a unicorn, is some Sublime Text. So I heard this from my friends that like Sublime Text actually, they actually get like a revenue of about like $1 million or so. And so the founder, like the 1 million revenue, probably they can't grow a lot much bigger than what they have right now. But as a founder of this company where you literally have like zero cost of production, there's actually making a lot of money for themselves. And yeah, so it's a very good outcome. So you just need to think about like, as a company, which direction do you go? So on our side, for time, when we were thinking about this, we knew that like we wanted to try something that like we want to try shoot for the moon. You know, if things fail, then sure we'll just go back and work for like be a software engineer at some other company. But you know, if we want to try something, let's just try it big. And also realize that the thing that we're building actually has a potential of becoming a huge market, and that's why we think maybe VC funding will help us get there faster and kind of scale quicker. So that's why we went for VC funding. So things you want to watch out when you're doing a Devtool startup. These are the three like big bullet points that like investors, or I guess folks in this space, will think about or ask you. And as an entrepreneur, if you're starting something in Devtool, this is definitely something you need to think about. So the first is the build versus buy mentality. This actually exists beyond Devtool, but it's a little bit stronger in the space of Devtool, in the sense like this question will come out a little bit more often. And the second is like, the question is like, why wouldn't you make it open source? This is a question your customers might ask you if you're trying to sell them something. Like let's say you wrote some code that they can, like you wrote some really cool library that do something really great. Then they'll ask you, hey, are you just trying to like sell this because you wanted to make money? Yeah, or are you making this a business because, you know, like why not just make it like free for everyone to use? You know, it costs you nothing to share it, right? It costs you nothing to kind of replicate it. So why do you want to charge money for it? That's kind of the mentality that a lot of developers have, and usually it's a valid concerns in terms of that. Like sometimes, like if it's not hard to make the thing that you are trying to sell them, someone else might try to create an open source version of the thing you're making and kind of undermine your business. And the last question that people often have is like, how big is the market? And because like, I mean, how many developers are there in the world? And like, if you're only targeting like, let's say you're only targeting developers that code for iOS, that only use a certain payment types, maybe that's like a too small of a market. So that's something that you want to watch out. Like, what's the upper bound of the market that you are kind of targeting? So for us, we the three things, this three kind of like things to watch out. There are like ways to kind of not avoid it, but like if the idea they have built is kind of against it, or like have strengths that would like kind of counter these things, then that will make it work. So for example, for the build versus buy mentality, because we are kind of building this code collaboration tool for people to code on some sort of like an editor, it's just simply too out of the way for people to build it, because like as a developer, oftentimes you don't really go build your editor that you use. As opposed to like, let's say I'm selling you a web server, then you might ask me, hey, why can't I just like make my own web server? Why should I buy the web server you made? Um, so for first question, we really are not like, people don't really usually have the build versus buy mentality when they kind of consider our product. So regarding why not make it open source, oftentimes open source products, if they are just like a library, but if it's very complex, they can spin out to become a company. So for example, like Databricks is a company where they created this kind of open source tool called Spark that let people process huge amount of data in a distributed way. So the underlying like technology of Spark is open source, but then they created this kind of a supporting company that kind of helps create a hosted, they have a hosted version of Spark where they can run things from there. And they also kind of do consulting for kind of developers using Spark. So that's kind of where they make their money. And the other alternative is if your product is open source, but you're bringing a dev tool, but there's a huge hosted element to it. Like for example, ngrok, where ngrok just lets you kind of tunnel the things that you're building out into a web, and so everyone can kind of see it from the open web. When you have a hosted element to it, open source developers tend not to like it, because like, sure, open source developers are like the enjoyment of like writing the code, or like having like someone building something new and something cool, but they don't really like to have to go through the pain of like having to wake up at like 10, 12 a.m. in the morning to kind of bug fix something and kind of get the server back rolling again. It's just too much of a commitment for something to do for free. So oftentimes when you have a hosted element to it, it will actually make your Devtool startup easier to sell. And I guess the last part is that for a potentially small market for what you're building, since all developers are part of the potential market here, hence the market that we can possibly target might actually be not that small. So, so in some sense, we kind of have proposed reasons of like why we might still succeed in this space. Yeah. So before I go into the book rec, so yeah, so given like this Dev2 startup, for what we're building, we kind of like managed to address all of them. But there's this one big question that we get from a lot of developers, is like, developers tend to have like a huge attachment to the editor that they're using. And that makes a lot of sense, because like as a developer, you kind of have your editor is kind of your environment that you spend all your time working in. It's like your office in some sense, where you have to, so oftentimes you kind of spend a lot of effort, a lot of time into like the setup, into developing your habits, developing your workflow, kind of all this like muscle memory you have to it, and then to ask you to switch out of it, of course, you develop a huge attachment to what you have set up already, because that is what makes you productive, and you wouldn't want to kind of switch it out. But one thing that we noticed that kind of supports this trend was that I don't support the trend, but like one thing that we noticed that might actually have helped was that VS Code was getting a lot more adoption in recent years. It started maybe 3 or 4 years ago, VS Code had like 10% adoption, but over time they became 30%, 40%, 50%, and I think 70% of the developers now, and all this in the Stack Overflow survey, said that they have tried and used VS Code before in development, which is a sign that like maybe there's some sort of convergence into the capabilities of editors. And VS Code is an open source editor, and hence, if we can make something that kind of matches the behavior of VS Code, then we might be able to kind of get developers to at least not have such a huge switching cost. So yeah, so then that's kind of how we kind of overcome the challenge. And then this is a funny story that kind of comes from this book. So this book is called The Art of Doing Science and Engineering by Richard Hamming, which is like I think it's a physicist, if I recall correctly, that also did a little bit of computer science, and he did some pioneering work in error correction code. So the reason why I recommend this book is because I mean it's generally a very good book to kind of read, and there's like this little anecdote from the book where like when Richard Hamming was kind of using computers, so he was there when like computers first became digital. Before that, computers were referred to women that actually did calculations for like what for the scientists or whoever that's like hiring them. So they're called computers, even though they are people. But then slowly they started to build computers. And when computers first started, like people had to code in binary or like in pen and paper and punch holes. But then like they had to code in binaries and they had to debug in binary, which is like a pain in the ass if you actually did anything that is even close to assembly level of coding. But then after a while, they introduced something called symbolic programming, and eventually Fortran, which is like one of the first few languages that were kind of symbolic programming in the sense that you don't have to kind of look at the ones and zero anymore of like the execution instruction and also the kind of the memory. Instead, you can just like use symbols like let a equals x, let a equals 2. So when they first introduced that symbolic programming to the existing programmers, they all hated it. They thought coding with like symbols is for sissy. So that's literally what they say. And they would actually just prefer debugging in binary. But to us right now, like in retrospect, this seems very obvious that no one's going to want to code in binary. Like we all want to operate in a higher abstraction level. But to those people that are stuck in their existing workflow, they were kind of resisting changes in their workflow, even though ultimately is going to make them like 10 times more productive. So that's the same kind of learning there. I kind of also apply in terms of like when we pitch the product or when we kind of try to convince, when we think about this product that we're building, which is like a multiplayer editor, because like people would inherently be resistant to any changes, even though there can possibly be like a huge productive gain from kind of allowing them to kind of code together collaboratively. So yeah, so this is just like an interesting story from this book. Generally this book is pretty good in like guiding you in terms of how to think. So maybe something that you might want to just check out. So our first big mistake was that we got into fundraising / acquisition talks when we were not yet ready. And that's because we kind of got led into this talk. So for example, for the fundraising talk, that was like when my partner and I were still kind of debating, hey, what should we do next? Should we just kind of work on this idea part-time? Should we kind of go full-time and raise the money? We were having these debates, but when we when we kind of communicated to some of our mentors that we were working with, they kind of maybe misunderstood or maybe intentionally misunderstood, we're not so sure, but they kind of connected us to folks to start talking about it. We thought initially, hey, it's just like a friendly discussion, get to know each other. Maybe when we are ready to fundraise, we actually go into to talk. But then like when we jumped in meeting, they started talking to us about like the valuations. And that's when we had a huge shock. So like this guy that we were talking to, he was like the co-founder of Tinder, which was like to someone like me that has like already met like famous people, it seemed like wow, this guy's a big shot and he's like offering me this valuation. This seems really cool. Maybe I should really think about it. But the fact that like when you get into this kind of fundraising mode or things that you're not ready to do, you actually spend a lot of time sink, because like when you're not ready, you kind of have some suboptimal arrangement. Like maybe you haven't arranged all your other investors meeting to kind of make them compete each other to give you the best offer that you can get. And also it kind of wasted time from both parties, because like in the end we had the time, hey, actually give us like 3 more weeks, we need to think about this more properly. But then he was like pushing really hard. It's like, hey, let's move fast. I like guys that move fast. You guys should kind of get back to the answer to me. So that was the case for us. But luckily we were able to get we would move forward from there, but we wasted quite a little bit of time from the suboptimal planning. So don't go into fundraising mode or like acquisition talks when you are not planning to do that. So the last part I'll kind of cover really quickly is like what we did in terms of like building the product. So another book that I really recommend is this book called Inspired by Marty Kagan, on how to create tech products that customers love. So one of the big lessons from this book is that you should always try to use prototypes and experiments to kind of move fast. So in a startup, you have very limited resources and time. So you have limited money, you have limited time, you have limited manpower. So unlike a big company where like you can make mistakes and like survive and like, just roll through the revenue that your big company is earning, you actually have very little margin room for error. So once you if you go back and you spend too much time doing things that didn't work, you actually kind of decrease the chance of your company surviving. So instead of like you having to build a huge, humongous product, maybe it's easier to it's actually less risky to like come up with tests or proxies of experiments that you can do that would take orders of magnitude less resources. So like maybe for example, something that we had to do was like we had to kind of build a VS Code editor or like a VS Code Lite editor in a short period of 3 months. But there was like some uncertainties there. Like we didn't know, oh, is it possible to do it? Even if it's possible to do it, like would people use it? If they use it, what sort of use case are they gonna care about? What should we focus on? And all these questions seems like things that maybe only after you build it can you figure out the answers. But there are always like tricks that you can do or ways you can kind of estimate by doing little experiments. So for example, we kind of like figure out some of the open source projects that did something similar to us and like see whether we can kind of pull their code and like replicate what they're doing and kind of understand where they're going, and just write a very quick, dirty prototype of doing the same thing as they did, just to test whether the concept is possible. And once we know that the concept is possible, then we actually spend the dedicated effort of trying to like make things work in a proper engineering way. So yeah, so we tested a lot of things, prototype, and from there so when you're building a product in the startup, there are like one of the main considerations like, do you want to build a maintainable code base, or would you want to build something that's really quick and then throw away? And like as a CS student or someone that's taught to engineering, trained in engineering school, it feels like the second part is like something that you should not do. The first part is like the build maintainable code is something that you kind of have been trained. Some they code review you, and even when you join internships, when you join big companies, that's what they kind of tell you. You know, you want to write good code, and then something that's maintainable. But when you're doing startups, when you're doing prototypes, and when you're kind of building things really quickly just to test certain concepts, you might just want to build some things really quickly, and then once you kind of validate your hypothesis, then you kind of just like build it and move on, because maybe that thing that you made wasn't useful, or maybe the thing you made super useful and actually people are using it, and then even when they're using your very janky, very shaky product, that's when you know that, okay, maybe this is you hit something there. No, we should try to make something that's a lot more maintainable. So one of the considerations that we had was like, should we fork VS Code, or should we just make a DIY Monaco? Monaco is the editor that VS Code is based after, and kind of string the other custom parts out of it. And the other consideration that we had for making things multiplayer was that we need to think whether we want to use CRDT, which stands for conflict replicated data types, or versus operation transform, which is another way of like kind of resolving the different inputs that user have in the text into one like consistent output. So like these are all different considerations we had to kind of think about like and balance, and eventually make a decision of like based on the constraints that we as a startup is facing, we have to kind of make the decision of what to make next. Yeah. So beyond the building product, so this is kind of like the grand vision. This is like I just made this in like 5 minutes, which is of like grand vision of what we are making, which is what time have now. So in some sense, right now in coding, there's like the asynchronous coding where you kind of use Git or to kind of collaborate your friend, or synchronous coding collaboration where you kind of just either sit next to a friend, sit next to your teammate, and then just code together, or you kind of screen sharing what you have. What we want to do is like there's this kind of this dichotomy. We want to just kind of merge both into one thing where people collaborate just by sending something over, regardless whether it's synchronous or asynchronous. So it's very similar to Google Docs. You don't kind of think whether I should commit into Google Docs or whether I should work with them in person right now. You kind of just send the link over to them, and then eventually, if both of you are online at the same time, great, you can kind of just work on it together. But if the both of you are like, one of them is offline, you can just work asynchronously. You don't have to like make the decision of, is this going to be like a synchronous or asynchronous collaboration? And the other part is like the coding env and the review env environment that people have. Like right now, people often code on the editor, but they review on GitHub, which is fine actually. But like, which is fine for most use cases. But like, there are certain situations where it's actually much easier to kind of read through the code, or maybe you want to test the code you're building, and hence this separation of the coding environment, the review environment actually makes certain things a little bit harder. And the last thing that we also want to kind of merge was like, now people like to track their source code with GitHub, source code Git, but they don't track, but everything else like the environment variables, the dependencies that they're using, I guess the dependency environment, or like secret codes, like API keys and stuff, they all like track in a different way, because like you're not supposed to add things to Git because it's dangerous. We think that kind of thinking is no longer relevant. No longer like that can be a better tool to kind of manage all this instead of having us to send to each other, send the stuff over Slack message to each other. So in some sense, the grand vision of our product is to kind of fuse everything into this, from this dichotomy into this like single point in the center, and hopefully that will become like a big enough delta, big enough change in the coding experience that most developers will switch into what we're making. So what's next for us is that we just launched our beta product. So you can check out our thing on time.so, tim.so to try out the beta. since a lot of you, I believe, might be computer science students. And now that we have kind of made a initial prototype, not prototype, but I guess like a very minimal product that we have of just a synchronous product, we are going to like the fundraising mode. And we are also hiring both in the US as like for interns or full-times, and we might eventually also expand to Singapore. So you might want to check out our website on time.so. There's like a link on the in that landing page that talks about hiring. Yeah, so that's all of my talk. So if you have any questions, feel free to just type in the chat or like just ask me. But otherwise, thanks for the time. So Joel asked, what code should we use to sign up for the beta? So the best way is that you go to time.s. Actually, HTTPS that. Go to this link that I sent in the group chat, and then once you kind of click the get access link, we will actually manually send you the email very soon after to kind of just give you the access code of how to get started with some instructions on how to get started. So that's the best way.
So if there are no questions, thank you, Ying Hang, for your insightful talk. And we'll be having a 2-minute break while waiting for the second speaker to set up.
So I'd like to thank everyone for the time for having me here. But I think since it's 3 a.m. here in the Pacific time, I think I'll go to sleep right now. And I hope you guys had a great Friday evening. Okay, bye-bye.
The second speaker will be Sheng Yu, who will be talking about Ktor. Sheng Yu is a developer advocate at JetBrains, and he is fascinated with researching new technology and fond of skills that increase productivity, and in charge of promoting technology such as Kotlin, IntelliJ IDEA, and provide solutions. He passionately contributed to open source communities and contributed to those for over 7 years. So let's welcome him.
Okay, hello everyone. I'm Sheng Yu. It's nice to have me tonight. And I'm a developer advocate at JetBrains. So basically, my responsibility is to introduce our product and our technology to the developers. So including the IntelliJ IDEA IDE and also the Kotlin programming language. So today I will want to talk about Ktor. It's our web framework building using Kotlin. So I will introduce what is Ktor and how to build a web API in about 30 minutes. Okay, let's get started. So before we jump into the Ktor, but I want to spend some time to introduce what is Kotlin. I think most of the developers know Kotlin because the Google Android team choose Kotlin as their primary language. So therefore, you must be familiar with the bottom right corner that you can use Kotlin to write Android application. But actually, in the beginning, Kotlin was targeting JVM. So it's you can imagine that it's kind of a Java replacement that bring many syntax sugar, modern language tool chain, and more. So Kotlin could be used on the server side. You can see the bottom left corner. So also, I want to mention that if you have ever tried IntelliJ IDEA or any JetBrains IDE, the IntelliJ IDEA platform is written in Kotlin. So we want to have a more modern language and with some syntax sugar and reduce the error. So basically, you can use Kotlin to write desktop application as well. So not only server side, but also desktop application. And you can see the top right corner, not only Android and server side, thanks for the Kotlin native project, you can use Kotlin to write iOS app. So in the last year, the Kotlin team released Kotlin multi-platform mobile to help you to write multi-platform mobile app. So it's kind of a framework and a plugin for Android Studio. So that plugin could help you to create a Kotlin multi-platform mobile project in Android Studio, and you can write a Kotlin code for Android and iOS app, and we can use Gradle to publish the application into the Android platform and iOS app store. And also, it must sounds crazy. You can also use Kotlin to write front-end code. So we had Kotlin.js. That means Kotlin compile could convert your Kotlin code into native JavaScript. So basically, you can see that in this diagram, Kotlin could be a multi-platform language to help you do almost everything for every platform. I know that we can do a lot with Kotlin, but today I will focus on the server side because I'm a backend developer. So I will introduce you a web framework from JetBrains called Ktor. We know we can build a web application on JVM, but building from scratch is tedious. So you need to manually handle HTTP requests and response and the status code, etc. So in JetBrains, we need the lightweight framework that could easily build microservice on for our new product space. So we built Ktor. It's the web framework that has both server-side component and client-side component. So for the server side, you can use Ktor to develop a web API or web page. And for the front-end side, you can use Ktor HTTP client to request HTTP request and get the response from another server. So it leveraged Ktor also leveraged the asynchronous feature. So in Kotlin, we have a framework called coroutine. So if your framework could support coroutine, that means you can handle the asynchronous request and response. That means you can bring more performance to your application. And we open source this framework under Apache 2.0. So if you have more interesting on that, you can go ktor.io to know more detail. And we have complicated documentation on our website. So today I will use Ktor to build an API service. So in this slide, the HTTP request is coming from our client, no matter it's from a web browser or a mobile phone. The HTTP request will go into our Ktor application. Then we will connect to our database and return the result using JSON format. In this case, we will use MySQL for our example. So let's start by creating a new Ktor application. So back to my IntelliJ IDEA. So you can see my desktop. This is IntelliJ IDEA Ultimate version. And in this welcome screen, let's click the Create Project. And in IntelliJ IDEA, there's a lot of different project templates that you can choose. One of the project template is Ktor. So in the newer version, IntelliJ IDEA already bundled the Ktor plugin into the IDE, so you can use it right away after you installed. So let's choose Ktor, and you can give the project name, for example, Ktor in action. And then we can store this project under our IntelliJ IDEA project. And you can choose either Gradle Kotlin DSL or Gradle Groovy or Maven, because I want it 100% Kotlin, so I will use Kotlin DSL for Gradle. Then you can design your package name. So for example, I will say my package name is craftsman.io. This is my website, and we will use this for my package name. and then you can choose the Ktor version. So basically, I will use the most stable version 1.6.7. And any other option, I will use the default choice. So the next step is to you can decide which plugin you want to use in your Ktor application. So let's back to our slides, and I want to introduce what is plugin. So in Ktor, that you can see it's a very lightweight framework. If you have another programming language experience that you might heard about Express.js in JavaScript, or Sinatra in Ruby, or Flask in Python. So it's basically the same concept in Kotlin. And it had a routing mechanism and was assigned to a handler to process the request and return the response. And between the handler, we could install as many as plugin you want, and to bring more feature into this application. So you can imagine that a plugin is sort of an ability. So that is the ability for the application. So for example, if we want Ktor to handle JSON, because we want to build a web API and we use JSON format for the request and response, so we will need to install a serialization plugin in our Ktor application. So back to our IntelliJ idea, let's search JSON in the plugin. So I will install the Kotlin X.serialization. Is a Kotlin multiplatform library using a design for the Kotlin team. So I will add this plugin into my Ktor application. Also, Kotlin X serialization has dependency with content negotiation and routing plugin. So Ktor plugin will notify you that you need to install these third plugins to have the ability to handle JSON. Okay, so you can see that we have installed 3 plugins for our application. Then we will click finish. IntelliJ IDEA will help you to create a new plugin using the Ktor project template. So you will spend a little time to process the Gradle build. The Gradle will help you to install all the dependency from the internet, and also it will create a project structure in IntelliJ IDEA. So during its running, let's back to our slide, and we can think about how we can design an API. So in this sample, I would like to have 2 kind of API. One is just a Hello World API. So we will design a URL. Is from document root and /hello, and it will accept application JSON format. If you open your browser and hit this URL, then Ktor will reply JSON format, and it contains a message field and also hello Ktor in the message. So that's our first API. And the second task we want to do is we want to create a product API. So we will design our API just like we will use the root URL, and then we will append API/v1/products to have the versioning and also the product naming on our URL. And this HTTP route also accept application JSON. So that's the API design we want to do. So let's back to our IntelliJ IDEA, and you can see that we already finished the initialized build. So we can open up the file under Kotlin and application.kt. So every Kotlin application, we will need the main function. It's kind of an entry point for application. So if we want to run this application, we just need to click the green play button in IntelliJ IDEA editor Ktor. And then in this main function, we will have an embedded server. It's a top level function that will help you to initialize a Ktor application. And inside this Lambda, we have two functions. One is configure routing and one is configure serialization. As we mentioned before, that Ktor is structured by several plugins. So if you want to add some ability to your Ktor application, for example, we want to add Hello World API and product API, then we need to add more and more plugin inside your Ktor application. So let's take the serialization plugin, for example. So in this serialization.kt file, you can see that in the beginning, we install the content negotiation plugin into this route. And then we say we want to use JSON handler to serialize and deserialize our string into the JSON format. And Ktor, it provides a very beautiful DSL syntax to help you to define your application route. So as you can see that you just open up a routing Lambda. And in this Lambda, you can say that I want to have a route that is, the URL is JSON/Kotlin x-serialization, and it will accept the HTTP GET method. And if anyone hit this application route, then the application will return a map. The map, the key is hello, and the value is word. So after Ktor passing this map into a serialization plugin, the serialization plugin will serialize this map into a JSON string. So that's the magic behind the application. So if we want to implement the first API, the Hello World API, in this application, the thing we need to do is to change the URL to hello. And then we need to change this map. We said that we want to have the key is message in the map, and the value is hello Ktor. Okay, it's super simple, right? So if we want to run this application to test our result, then we will switch to application.kt and hit this green button. And IntelliJ IDEA will help you to compile this source code and run your application. Okay, so you can see that our application is running in our localhost 8080. So let's open up a HTTP request sketch file in IntelliJ IDEA. So head to our project panel, and you can use the shortcut Command N, and we can create a sketch file, and the file type is HTTP request. In this HTTP file request, you can imagine that this is kind of Postman in IntelliJ IDEA. So you can say that we want to have a HTTP GET request, and we will hit the localhost 8080 and /hello, and we will accept the application JSON format for this HTTP response. So then we can use the shortcut Option Enter to actually run this request. So IntelliJ IDEA will request to our application, and our application will return the JSON format for us. So you can see that our JSON result is a hello world message. The key is message, and the value is hello Ktor. That is exactly we designed in the application route. Okay, so we finished the first task to build up a Hello World API. So the second API that we want to build is a product API. So we can continue writing in this routing DSL. So we can open up a get function, and in the path parameter, we can say that we want to have a URL /API/v1/products. In every application route, Ktor will pass the call object. The call object is an application code. And if you see our application, our slide, and application code is the diagram that we display here. It includes HTTP request, our routing, and our handler and the response. So basically, Ktor will give you the application code object. Then you can set up, you can receive the data from the request, and you can also set up the response for the application. So back to our code. So we can say that we want to have a response, and we also give it a map. And in this map, we want to, for example, our key is data, and we want to give Ktor a product. The product is a list or array to store all of the product information in this variable. So we want to return these products to the user. So, but we don't have any products, right? So we have to design our product, our product structure using data class. So in this API, we want to, for example, return 10 items of product. So I want to generate a list from 1 to 10. Then I want to map this integer into a product DTO. So product DTO is kind of a data transfer object, and we will implement this DTO using Kotlin data class. So as you can imagine that which kind of data will include in a product. For example, we want to have an ID, and the ID might be an integer. So we can get it from the list. So we can use it to represent the integer in this list from 1 to 10. And second, we want to have a title. The title might be, for example, product. And we can give in a number. Then we will have a description for the product. And also we will have a price for product. So for example, our product price is 100.0. And our product system have a ranking. So we will have a rating column for the product. So the rating is from 1 to 5. So maybe 4. And also we will have a thumbnail. It's a product image. So the product image might be a URL for the image file. So we can say, for example, www.image.com/product. And we can have ID in the product name. Okay. Then we will store this list into map. So we will use postfix to generate the variable from the list. So now we have products. But you can see that here is the red code in IntelliJ IDEA because we not actually define what is product DTO. So you can place your mouse cursor and hit Option Enter to create a class called project DTO. And I will store this file under the, for example, DTO folder. Okay, so you can see that IntelliJ IDEA is smart enough to generate the code for you. And because we already assigned the parameter for the product DTO, so IntelliJ IDEA will revert the data type for you. So basically, you just hit tab to every parameter. And then we don't need the curly brace, and we can put parameter on separate lines. And we say that this class is kind of DTO, so it's a data class. For data class, you have to define every property to value. Okay. And we will send this data class into serialization plugin. So you have to add a notation to determine that this data class could be serialized. So let's add a notation, serializable, and we can import it from the packaging. Okay, so now we finish this part. You can see that the red code was gone. So in this product API, we will generate 10 fake product DTO from the list, and we will store in the variable. Then we will put it into a map and serialize to the user. So we can restart our application by hitting the run button. Okay, you can see that our application has been restarted. Then we can have another HTTP request in our Scratch file. So this request is also using HTTP GET method. And then we can go to API v1 products. And we also accept application JSON. So let's see if we successfully finish this part. Okay, so as you can see that our application will return 10 products using JSON format, and every product have its own ID, title, description, price, rating, thumbnail, and the data is a little bit different between the product. And all the products were stored in under the data field. Okay, so we've finished the first stage, and then we want to make this application more dynamic. So I will use a fake library to generate fake data in our product to make this API response more real. So you can open up the dependency panel, and every time you want to manage your dependency, you can open up your build.gradle.kts file. And we can search, for example, we want to have a Java Faker library from our application. Okay, so basically, this dependency panel will help you to search the Kotlin or Java library from the internet. So we can see that the first result is what we want, is a Java Faker library. So we will click Add, and IntelliJ IDEA will help you to insert the dependency declaration in your build.gradle.kts. So let's refresh our Gradle. Then we will have the Faker plugin. So back to our serialization. In this API, we will need to have a faker object from our newly installed plugin. So this is the library that we just installed. And then we need to initialize this object into an instance. Then we can change the content in our product DTO. So for example, in the title, we can use faker to generate the Lorem Ipsum to have, for example, sentence. And for the description, we need more sentence. So we will use faker to generate the Lorem Ipsum for the paragraph. For the price, we need some random number. So I will use the random library that from the Kotlin standard library to generate the double number from the library. So for example, we will generate the price from 1 to for example 1,000. Okay, for the rating, we can also use the random library to generate the integer from, for example, from 0 to 5. Okay, for the thumbnail, we will need, we can also use faker to generate the internet thingy, and we can generate the fake image from the internet. Okay, so that's what we did. And then we can restart our application. So this time you will see that the result in our JSON format will be a little different. All the data will like a real data. So let's hit our HTTP request again. As you can see that this is the previous response, and this is our response from this time. And we can compare two response using IntelliJ IDEA. So you can see that in the right hand, that is the original the API response that only generate the product 1, 2, 3, 4 to 10 is kind of not that real. But in the left hand, you can see that all the title and description are generated using the Lorem Ipsum, and all the price and the rating are randomly. So that is more realistic data in our API. Okay, so I think we finished the second stage of our development. So the third stage, we will need to have a database to store all of the data that we generate from the faker library. So before we use the database, we need a library that help us to connect to the database. So in JetBrains, we also have a library called Exposed. It's an ORM framework that both support the DSL style and the DAO style to write SQL query. We also open source in Apache 2.0. And if you want to know more detail, you can go to our GitHub, and we have a documentation to describe how to use Expose using DSL syntax or DAO. But today, I prefer to use DAO pattern. It's kind of, you can represent your data in a Kotlin class and object to represent your data in the database. So for the table that you can see that we will store a lot of different products in our database. So we can declare a object using Kotlin. We will name it products, and the table will use int for ID column and then we will represent our title, description, price, rating, thumbnail in the column. And each column have different data type. For example, title and using varchar, and we will use text for description, using double for price, and integer for the rating, for example. So products object will represent the table in your database. And then we need an entity. It's a calling class that basically look very similar with your product DTO, but it represents the data in the table. So we have a database that have several tables, and each tables will have several data row. So the products will represent the products table, and the product will represent a single data in the products table. So that's the relationship between the table and the entity. So back to our IntelliJ idea. So let's create a new package called entities. And I will add a new class called product. This is for entity. And I just want to save some time so you can see that I generate all the code I need for the product entity. Then we will create a new product package called tables. And also we need to create a products object for the table. Okay, so also I use the code generation to generate the code I need to save some time. And before we actually run this code, we need to add more dependency into our project. So open up the dependency panel. We need JetBrains exposed. This is the exposed library from JetBrains, and we can search in the in the dependency panel. And we will need core library. Let's open up the build.gradle.kts for the result. So you can see that we need core library, and we also need DAO because we use the ORM model for this project. Also, we need JDBC for the connection. And since we will use the MySQL, so we will need to add MySQL connector to connect to MySQL. So let's add dependency as well. So after we add all the dependency, don't forget to re-import your Gradle. And in the meantime, I will also add a new file called docker compose.yaml. And I will generate a Docker compose file to have a MySQL image to have a MySQL instance for my project. And also I need to initialize my Docker daemon in the background. Okay, so let's back to our entity and the table. So there are several red code. So just because we don't have the dependency before, so just use Option Enter to re-import all the necessary library for the file. Also, let's back to the tables. Use Option Enter so you can see that all the red code gone because we have the dependency. Okay, so you can see that my Docker daemon already running. So we can switch to Docker Compose. Just click the ring button. Then IntelliJ IDEA will help you to initialize the Docker container to have MySQL. So you can see that we already have a MySQL running in the background, and our root password is root. So let's try to connect to the database. So open up the database panel. You can add a data source using MySQL driver. And as you can see that in the port forwarding, we will forward the MySQL port to our local port. So in this port setting, don't forget to use our local port. And our username is root and password is root. Please don't do that because we are in the development stage, so we can use root for the username and password, but don't do that in the production. Okay, so we can add database, and then we will apply. So IntelliJ IDEA will try to connect to our MySQL server inside the Docker container. Okay, so that's the database we will need to use later. Okay, so we have our Docker container for MySQL. We have our product for the entity and products for our table. Then we will jump back to our code to connect to our database. So in our Ktor application, in the beginning, just right after the plugin install, then we will need to connect to our database. So you can see that we can use the expose database object to connect to our local MySQL server. So I will use the localhost and the simple database in our MySQL server, and use the right driver and give it the username and password. So after we connect to the database, then we can run some query to the database. So before you write the query to the database, you have to open up a transaction in Ktor application. Then we will use schema utility to create the table that we want. So our table definition is was definition by the product object. So in this create method, you just post the product table to it, and it will help you to create the product table in your MySQL database. Second, I want to create to generate some fake data and insert into our MySQL database. And then we will retrieve that data in our API. So I will borrow some code from here. So we will generate 10 product in this list. But this time we will use product entity to create a new entry in our database. And then we will use Faker to generate the necessary column for our product data. Then we will also need this Faker object in our transaction. Okay, and in this lambda, we don't need the semicolon. Okay. Okay, so I think we done for the generation. Then we will temporarily comment this code for later use. And let's just restart our application to see if we successfully insert all the generate data into our database. Okay, so I don't. Okay, let's do that again. Okay, as you can see that expose will generate the SQL query for you and insert the data into database. So this time we refresh the database and we can see that here comes a new table called products. And if you double click the product name, then it will show the content in the database. So that's the 10 result that we generate in the database. So we successfully generate and insert the data into database. So the next step we want to do is to retrieve the data from the database. So let's comment up. So in our API, we also need to open up a transaction to retrieve the data from database. So this time we will use product entity to retrieve all data from the database. And then we will remap all the data and transfer it to product DTO. Because we could serialize the product DTO, but we cannot serialize the product entity. So just use the mapping technique, then you can transfer your object into another type of class. So in this product DTO, we will use, for example, ID, we will get from the entity and the ID column, and we will retrieve the value from the column. Then we will convert the title, also the description, the price, and also the rating. Okay, so I think we done for this part. So after this transaction, all the product will convert into product DTO. So we could store into a variable. So we can use products as well. So since we use the same name of the variable, so we don't need to modify any code in this line. Okay, so this time after we restart our application, we can retrieve the data from the database. Okay, so let's restart our application. Okay, so you can see that our application is running, and we can switch to our HTTP request. So let's hit the API again. You can see that each time we restart our application, Ktor will generate 10 items and insert into database. So this is our second time to restart the application after we have a MySQL server. So now we have 20 products in our database. So you can see that the first one is something like that. So we can see the result and compare the title from the database and our API result. So you can see that we have 20 products in our API, and also it reflects from the database. So that's basically all the development from using the expose and MySQL database. Okay, so we almost done. So the final thing we need to do is to pack this Ktor application into a container. Then we can deploy this container into our Docker registry. So you can see that the pack and deploy workflow is something like that. We develop our source code in IntelliJ IDEA. Then we will use a tool called Jib that is developed by Google Cloud. It will help you to generate the Docker container and put your application into the container, then it will also help you to upload the Docker container to your Docker registry. And it support various registry from the internet. So you can upload your Docker image to Docker Hub or GCP or Azure or AWS or something like that. And then you can deploy your image to your production server. So before we pack our application, we need to install the Jib. That is a Gradle plugin to help you to automate this workflow for you. So we need to open up the build.gradle file and add a Jib plugin in your Gradle file. So back to our build.gradle.kts file in the beginning, that will have the plugin definition here. So we will add Jib plugin in our Gradle. So we import your Gradle, it will download the Jib plugin and install it. So after we install the Jib plugin, you can see that in your Gradle panel that we have a new task group called Jib. So you can see that we have the Jib command, and then we can use it to generate the Docker image. So before we deploy, let's jump into our my Docker Hub. I need to create a repository to store my image. So let's create a repository. We can call this image like Ktor-in-action, and let's create. And this image will name by Shen You Fan / Kotlin in action. So that's the image name. So back to the IntelliJ idea, we can add a parameter into this Gradle task. We can say that our image name will be Shen You Fan / Ktor in action. Okay, then we will run this Gradle task. So you can see that after the Gradle run, it will compile your Ktor application and try to pack it using Docker image. And after the image was successfully built, it will okay, we don't have the authentication, so don't worry. Let me log into the Docker Hub and open the Docker dashboard again. Okay, so you can see that I already logged in, so we can rerun this command. There might be something wrong. Okay, I think there's something wrong in my JDK, but don't worry. If you try to follow the step, you can do the same thing that we, you can upload this image to Docker Hub. Okay, so let's do a recap for today's talk. So the first one, we talk about the Kotlin multi-platform diagram that you can use Kotlin to develop almost everything. You can develop Android app, iOS app, front end, server-side code, or a desktop app. And then we will focus on the web development using Ktor. So we introduce what is Ktor. It's a web application with a synchronized feature using Kotlin coroutine framework. And also we will introduce the idea of Ktor plugin, that each application code will handle the request and using the handler. That handler is kind of the plugin. So if you want to add more and more feature into your Ktor application, you need to install a lot of different plugins in your Ktor application. So in today's sample, we install 3 plugins in Ktor. One is JSON serialization, one is content negotiation, and one is the routing feature. Next step, we talk about the API design. So what the JSON structure looks like and how we reflect the JSON structure into the data class. So we have a DTO object, data transfer object, using Kotlin data class. So we have a product DTO to represent the JSON structure in Kotlin code. And then we will introduce how to write routing in your application. So you can open up different HTTP method and giving different HTTP URL to define your application route using DSL syntax. Then we handle the application request and response using the code object. We in the beginning, we just return a simple message, hello Ktor, and then we generate the fake product data. And third, we store the data into database and search the query from the database and return to the user. So that is the overall workflow that include the mock server and Java Faker library, also the expose ORM. So I think we spent about 14 minutes for develop a product API step by step. You can imagine that if you use Ktor to develop a web API, it's quite simple and easy, and you can pack it to into a Docker image, then you can deploy. So hope you enjoy this talk. And if you have any question, just let me know, and you can type in the chat window. And here is my email. If you have any question and you want to keep in touch with me, then you can write to me by email. So thank you. So I will temporarily close my slide. I will jump into the chat window to see if there is any question. Okay, so here is the question. Do you have any interesting example of apps that people have built using Ktor? That's a good question. So in JetBrains, we say we eat our dog fooding in our team. So if you head into the JetBrains official website, you can see that we have a new product called Space. Space is an all-in-one platform that combines all the tools that you need for the web development or software development, that include chat feature or Git hosting, issue tracking, and CI/CD, and all the feature that you need for the web for the software development. And this is kind of the very big platform for the product. So this plugin is structured by several microservices. And I mentioned that Ktor is a perfect fit for the microservice because it's lightweight, it's asynchronous, and you can easy to develop a microservice and pack into a Docker image. So you can see that Space is one of the example that using Ktor to build a microservice for the product. And also you can see the Ktor website. And I think there's a lot of different CTO or other team lead that they say that they use Ktor to develop their product. So if you are interested, you can see the official website for more detail. And also you can go to the Kotlin Lang official website. And for the server side, you can see that there's a lot of case study. So as I know that many of the case study here are using Ktor as their primary framework for their development. So if you are interested, you can go to the, for example, to the Expedia, and they will say that how they use Kotlin to write server-side application. Okay. Welcome. Are there any features of Kotlin that are particularly useful for Ktor's use case? I have not used Kotlin before. I will say that for me, if you have some experience from Java, I will say that data class is a very good syntax sugar for you, because in Java you need to write a POJO to store the data, to represent the data. But in Kotlin, you just need write data class and set up several parameters for the class. Then this is represent a POJO in Java. But you can imagine that in Java you need to write several boilerplate code to represent the POJO. So if you didn't write Kotlin before, I will say that you can use data class in the first time to define the data structure that you want to represent. And also, personally, I really like the collection syntax in Kotlin. So you can see that I use that several times in the demo, that you just use 1.10, it will represent a list in Kotlin, and you can immediately transfer this list into another class. So you can use this mechanism to transfer a list from 1 to 10 into a product list. So I will say that these two syntax is my most favorite syntax in Kotlin, and you can use in the Ktor right away. Okay, so the question is about, are there any performance benefits that come with using Kotlin? I will say that the most benefit from Kotlin is about the syntax sugar. And if you are familiar with the asynchronous programming, then you can use coroutine. It will reduce a lot of work to handling thread or multitask. But Ktor, Kotlin will compile all the source code for JVM. So basically, it will convert the source code into the binary code running on the JVM. So I will say that it will not much benefit from the calling in the performance performance part, because it is still running on the JVM, so it's quite limited for the JVM. But if you try GraalVM, I'm not sure if you heard about that. This is a new VM from Oracle. And if you compile your Kotlin code using GraalVM that will sort of conceptually compile your source code into a native code. So you don't need JVM anymore, and you can get more and more performance benefit from this VM. So if you really care about the performance issue, then you can try this VM. Yeah, welcome. And as you can see that GraalVM also support different languages. So if you, for example, if you are interested in JavaScript or you write Python or Ruby, you can also use this VM to compile your code to native.
If there are no more questions, thank you, Sheng for the very insightful talk. And this will be the end of Friday Hacks 217, and we will not be having Friday Hacks for the next 2 weeks due to recess week and exam week. So see you in 2 weeks time.
Thank you for having me. See you next time.